For decades, humanity has gazed at Mars, captivated by its rusty deserts and mysterious valleys, wondering if it once harbored life, or if it could one day be a new home for us. We sent rovers and orbiters to unravel its secrets, each mission pushing the boundaries of exploration, mapping the surface and searching for signs of water and habitability. These robotic explorers revealed that Mars was once warmer, wetter, and possibly even a cradle for life, with ancient riverbeds and clay deposits hinting at a lost world. But to truly understand the red planet, we realized we had to look beneath its battered, wind-swept surface, where the real story might be hidden. Mars is constantly bombarded by harsh cosmic radiation, which erases delicate chemical traces and makes it nearly impossible to find evidence of ancient life on the surface. That's why the Mars Subsurface Explorer was built, to go deeper than any mission before, equipped with a revolutionary drill designed to pierce the planet's tough crust. By digging meters below, we could reach a protected realm, shielded from radiation and untouched for billions of years. A time capsule of Mars's ancient past. Imagine the surface as a weathered book, its story faded and torn by time. But deep underground, the pages might be perfectly preserved, waiting to be read for the first time. The drill was our key to unlocking Mars's oldest secrets, reaching places no human or robot had ever touched. Each meter down was a journey further back in time, through layers of rock and soil that recorded the planet's changing climate and chemistry. As the drill descended, scientists on Earth watched breathless, their eyes glued to live feeds and data streams, hoping for a glimpse of something extraordinary. Every layer revealed new clues about Mars's past, evidence of ancient lakes, volcanic eruptions, and perhaps even the building blocks of life. We were peeling back the planet's history, one core sample at a time, searching for signs that Mars was once alive, or could support life in the future. This was more than a mission, it was a bold step to answer one of humanity's oldest questions: are we alone in the universe, or is life a cosmic inevitability? The journey downward had begun, and as the world watched, we waited with hope and anticipation to see what secrets Mars would finally reveal. The Subsurface Explorer's goal was simple, yet profound in its implications for science and humanity. Find places where life could have survived, hidden away from the harshness of the Martian surface. On Earth, life follows water, so we searched for subsurface ice, believing it to be the most promising signpost for habitability. And we looked for organic molecules, the essential building blocks of life as we know it, hoping to find a chemical fingerprint of biology. Mars's thin atmosphere means its surface is constantly bombarded and sterilized by cosmic radiation, but just meters below, rock and soil form a natural shield, protecting anything beneath from the deadly rays. The mission aimed to test how well this underground sanctuary preserved evidence of life, acting as a time capsule for ancient Martian secrets. If Martian microbes ever existed, their traces would be safest here, shielded from the ravages of time and radiation. The drill was our archaeological tool, searching for whispers of a lost biological era. The mission was twofold: first to find habitable conditions, then to hunt for preserved biosignatures, chemical or structural clues that life once thrived here. Every centimeter drilled brought us closer to untouched Martian history, each sample a potential window into a world long gone. We ventured into a hidden world, where Mars's secrets might still wait, undisturbed for millions of years. The entire mission hinged on one idea: to find the truth, you have to dig for it, both literally and figuratively. This was our best chance to uncover Mars's most profound mysteries, to answer questions that have haunted humanity for generations. The stakes were high, but so was the potential reward: the discovery of life beyond Earth, or the knowledge that we truly are alone. We pressed on, deeper into the unknown, driven by curiosity and the hope of rewriting our place in the universe. As the drill descended into the ancient Martian crust, each rotation brought us closer to secrets locked away for millions of years. The data streaming back to Earth was immediately fascinating, sparking excitement and curiosity in the mission control room. At first, we encountered familiar minerals and patches of permafrost, confirming what earlier missions had hinted at. Mars's surface had once been shaped by water and ice, but at 10 meters our instruments detected complex organic molecules, intricate structures often linked to life on Earth, raising new questions about Mars's potential for habitability. The team was thrilled by this discovery, but the mission pressed on, determined to see what deeper layers might reveal. At 15 meters, sensors picked up traces of methane, a gas that, on Earth, is often produced by living organisms, but can also result from geological processes. The real surprise came at 20 meters. a mysterious signal, labeled Bio-A17, unlike anything in our databases, hinting at unknown chemistry, or perhaps something more. Bio-A17 bore a striking resemblance to the metabolic byproducts of anaerobic microbes found in some of Earth's most extreme environments, deepening the mystery. This was the most compelling evidence yet for possible life, igniting debates and cautious optimism among the scientific community. The discoveries at 10, 15, and 20 meters painted a vivid picture of a dynamic, chemically rich underground, layered with clues to Mars's past. We were closer than ever to answering the ultimate question: could life have ever existed on Mars, or might it still persist in hidden pockets below the surface? The drill had revealed a layered story, hidden for eons beneath the red dust, each stratum a chapter in Mars's mysterious history. Each new depth brought fresh intrigue and hope, fueling our desire to keep searching, to keep asking questions. Mars was proving to be far more alive, chemically if not biologically, than we'd ever imagined, and its buried treasures were only beginning to be uncovered. Just as the team celebrated the Bio-A17 discovery, disaster struck. The drill's resistance dropped, like it had broken into a cavern or slushy pocket. Suddenly, a massive plume of methane erupted from the borehole, far exceeding earlier readings. The lander shook as the pressure release rocked the site. Then the drill head's temperature spiked, an enormous, inexplicable burst of heat. It was as if we'd awakened something volatile deep below. In moments, all communication with the lander ceased. The data stream stopped, silence replaced discovery. Mission control was stunned, Triumph turned to blackout in minutes. Mars had revealed its secrets, then slammed the door shut. The red planet had pushed back, leaving us with more questions than answers. Though the lander was lost, our orbiters kept watch from above. High-resolution images showed the ground around the site had buckled and fractured, clear evidence of a massive subsurface event. The lander sat at the center of a new geological feature. Ground-penetrating radar revealed a large, anomalous zone beneath the drill site, likely a pressurized reservoir. The orbiters confirmed what the lander's final data suggested. We'd triggered a powerful underground blowout. Even without direct contact, we pieced together the story from space. The aftermath was visible from orbit, fractures on the surface, a new cavity below. Our remote detectives helped us understand the catastrophe. Mars had proven itself dynamic and volatile. The mission's legacy was now written in the Martian landscape. With the lander gone, scientists became detectives, piecing together the mystery. The leading theory: the drill punctured a clathrate reservoir, ice-trapping methane under pressure. The sudden gas release explained the eruption, but not the heat or blackout. Mars's crust contains pockets of strong magnetism. The theory suggests the gas and dust rushing past a magnetic boundary created a massive static charge, like a planetary-scale balloon rub. This triggered a colossal underground lightning bolt, frying the lander's electronics and melting ice and rock. The evidence: a drop in resistance, methane spike, heat surge, and total blackout. Mars's subsurface proved to be a volatile, interconnected system. We hadn't just found possible signs of life, we'd uncovered a new kind of planetary hazard. The red planet's mysteries had only deepened. The Mars Subsurface Explorer's story is one of triumph and mystery. It proved the Martian underground preserves the building blocks of life. The discovery of complex organics and the enigmatic Bio-A17 changed our view of Mars forever. Now Mars is a place of active, intriguing chemistry, maybe more. The mission's loss only sharpened our curiosity and resolve. Future missions must be tougher, smarter, and ready for Mars's volatility. We'll need new tech to drill deeper and explore these hidden reservoirs. The Subsurface Explorer's legacy is the new questions it raised. Exploring Mars is about more than rocks, it's about our place in the cosmos. By searching for life elsewhere, we learn about life here. The universe is full of wonders waiting to be found. That drive to explore is what makes us human, and why we must return.